In this unit, we're going to be learning about circles. So today we're going to start off by learning how to describe circles, arc length, and what arcs are. So when we're describing circles, there's a few different vocab words that we have. The first one, D, well, D is the center of a circle. Then if we look at this line AC, AC is a diameter. If we look at DB, DB is a radius. And then if we look at this angle BDC, this angle right here, this is called a central angle. And it's called a central angle because its vertex is in the center. Now we also have different kinds of arcs. So there are 3 different kinds of arcs we can have in a circle. And the words that we use make sense. So a minor arc, think small. So this is a type of central angle that is less than 180 degrees. A major arc, think big. This is a central angle that is greater than 180 degrees. And last up, you guessed it, a semicircle is a central angle that is equal to 180 degrees. So this is kind of like our half circles that we have. Now we can name minor arcs and major arcs and semicircles. The way that we're going to name an arc, so let's first try to find something in here that's smaller than 180. So one obvious one is AD. Instead of writing just AD, what we're going to do is add a little arc over it. So that's our minor arc. Another one might be CE because that's also less than 180. So we can say CE is another. Another arc that we have that's less than 180 would be AC. So we'll write AC. And lastly, another one we have is DE. So we can write DE. Now we're going to look for semicircles. So if you find the diameter, it's really easy to see a semicircle made from that diameter. So if we look at this diameter, one of the semicircles that we can see first is ADE. Now, instead of just naming this by the endpoints AE, what we're going to do is name it ADE. And the way you read this is it starts at A, it travels through D, and then it gets to E. So that's how you know that is the correct semicircle. On the other side, we also have ACE. So ACE. So if it goes through more than one letter, you can use that letter in the order. We also have another diameter right here. So we can name this arc, this semicircle, as DAC. Then we have DEC, which goes this way. So we have DEC. And did we get them all? I think so we got them all. And another thing that you can do is change the order. So instead of saying DEC, you could have also said CED. It's the same area that we're talking about. It just doesn't really matter which way you name it. Last step, they ask us for the major arcs that contain the point A. So we need some major arcs that go through this point A. One of them is ADC. This goes through A. It starts at A. So it goes ADC. Another one you might have realized is going the other way. So we could have gone this way. So that would be, we could say ACD. It would have also been fine to say AED. It's the same place. We also have, you can go around like this. That contains the point A. So that we can say is EAC. We could also say that's EDC. And DC. We also can go around. So we have ADC, we have EDC, and we have DCA. So we can really name these in a lot of ways, but those are some of the major ones that contain the point A. Next up, we get to arc measure. So arc measure is the measure of the arc. So if you look at this RT right here, well, it's made by this angle. So if we look at angle RST, that angle is 50 degrees. So this angle, we notice, makes up RT. So it would make sense then that arc RT is also 50 degrees. So if you can find the angle that makes it up, that's also the measure of the arc. So find angle measure to find arc measure, and you can use them interchangeably. You might also be wondering, if we went the other way around the circle, we went RQT, what's the measure of RQT? Well, RQT, if that it's missing 50 degrees, remember all the way around is 360. So 360 minus 50 would give us the measure of RQT, which is 310 degrees. So that's how you can figure out arc measure. Let's try a few more examples of that. This first one asks us for BC. Well, I know the angle that makes it up is 32, so BC is also 32. Next up, it asks for BD. So BD, remember if we use two letters, it's like a minor arc, and if we use three, it's a major arc, so we can just call this BD. It's made up by two angles, 32 and 58, so we say 32 plus 58, and we get 90 degrees. That's actually a 90-degree angle right there. Now let's look at ABC. ABC is halfway around the circle. Remember, that is a semicircle, so that's just going to be 180 degrees. It's halfway across. And last up, AB. Let's highlight AB in blue right here. Notice if this whole red arc is 180, AB would be 180 minus that. So 180 minus 32, which will give us 148. So remember, you can always use this whole circle has to add up to 180, or half the circle has 360, or half the circle has to add up to 180. Now, we've learned before the circumference of a circle. So the circumference of a circle is 2 pi r. So here's our formula. So if we know the radius r is 6 centimeters, then for this example, c is equal to 2 pi times 6, or 12 pi centimeters. Now, if we want to know the arc length is like I have a piece of the circle and I want to know if I walk from A to B, how far would I have to walk? So the way you're going to find arc length is it's going to be equal to a fraction of the circle. So if I know all the way around is the circumference, I only want to walk a part of it. So what I'm going to do is find out what's the measure of that arc out of the whole thing. Remember, the whole thing is 360. And then I multiply it by 2 pi r. So this is my equation for arc length. And what it means is I have a fraction of the circle. How much do I have? and I multiply it by the circumference. So just to make sure you know the difference between arc measure and arc length, here's our units. So arc measure is in degrees. Right, the little degrees sign. Arc length, think about walking some length. So arc length is a length, right? So it's going to be like centimeters, meters, miles. Let's try 2 examples, and it might make a little bit more sense. So let's figure out what we have first. In this circle, our radius is 15 centimeters. And we have this big arc right here, XPY, and we know the measure of arc XPY, they tell us, is 240 degrees. That's all we need to solve this problem. So the arc length of XPY is equal to the measure of the arc over 360. So how much do I have out of the total? Times the circumference, 2 pi r. So the measure of the arc is 240. So I have 240 degrees out of all 360 degrees, which is how much I have of the circumference, which is 2 pi times 15. If I multiply 240 over 360 times 2 times 15, I get 20. So I say 20 pi, and my units are centimeters. Let's try one last example. So in this next example, if the diameter is 16, all the way across is 16, halfway across is the radius. So the radius is 8 inches. And let's say I want to find the measure of XY. So the measure of arc XY, they tell us, since this is 90 degrees, the measure of the arc is also 90 degrees. Now, my arc length of XY is going to equal how many degrees I have out of 360 times 2 pi times 8. That turns into 4 pi inches. Notice this intuitively makes sense because I wanted to know if I walk from X to Y, that's a quarter way around the circle, right? My circumference is 2 pi times 18, which is 16 pi. If I want to walk a quarter of that, that would be 4, right? Because I divide that by 4, which is exactly what we calculated the arc length to be. So this is how much you have times the entire amount. So it's a fraction of a total.